right. So make sure you have your place value chart on your desk and your whiteboard marker. Awesome, great. So, attention up here, David. We are going to today, our learning goal for our math lesson is by the end of this lesson, you are going to be able to round whole numbers and decimals. I totally get it that maybe all of you, maybe most of you, potentially half of you have already rounded whole numbers, already rounded decimals. We're going to do a lesson on it today to revisit those skills, because when you go into your 6th grade math books, which are right up here, which is coming soon, they're going to be asking you to round to a very specific place value. It could be a whole number, it could be a decimal. So we're going to practice today and make sure that we feel really good about those skills.
Okay.
I'm going to show you a video to start about rounding. And in the video, I want you to pay attention. There is one rule that is different for rounding whole numbers than rounding decimals. Remember, decimals are our parts and pieces, and whole numbers are complete. It's not a part of a number, it's a whole number. So there is a different rule when you round a whole number than when you round a decimal. And that's what I want you to really pay attention for in the video. Turn and tell your partner, what are you paying attention to in the video? You can get up, Anthony, tell Rui real quick. Okay, you can get out of your seat. What are you going to pay attention to in the video? Can I have one person tell me what we're going to pay attention to in the video, Roman? What about them? We are going to round whole numbers and decimals. What am I going to pay attention to about rounding whole numbers and decimals? Anybody? There, that's a, oh, Annie? Yes, that's right. There's one rule that is different when we round whole numbers than when we round those parts and pieces. It has to do with zeros. That's my clue. Pay attention to what happens with the zeros. All right? Are you guys good? Yeah. Let me set up our movie theater speakers. What? It's easier to hear with than the projector sound. Okay, got it on. Hold on, the sound's not working. Give me a second. Technical difficulties, you know. This thing is called an anchor. Do you guys see it? No. Okay, so let's unplug this and we're going to use the projector sound. Gotta make it work. Okay, there's still no sound. I did, and then I unplugged it, hoping it would just play through the, here, projector. Here we go. Let's see if that works.
To help you understand what rounding is, let's think about how numbers are usually used. Most of the time, numbers are used to represent amounts of things, like how many miles it is to the supermarket, or how many days until your birthday, or how many students went to your high school. How many students went to my high school? Oh, about 2,000. Okay, but it wasn't exactly 2,000, was it? Well, no, it was more like 1,900. Ah, but it probably wasn't exactly 1,900 either, was it? Well, no, it was more like 1,860. All right, fine. 1,863. See what I did there? At first, the number used to represent the students at high school was a round number. It was a good estimate of how many students there were, but it wasn't exact. The next two numbers were a little closer to the truth, but they were still estimates. Only the final number represented the exact amount of students at the school. All three of the estimates are rounded versions of the exact count, but they have different levels of precision. 1,860 was the most precise estimate, and 2,000 was the least precise estimate. So rounding a number basically means making a less precise version of it. And as you can see, there's usually multiple ways to round a number depending on the level of precision that you need. A really good way to understand what's going on when you round a number is to look at a number line. Here's 1,863. If we want to round it to the nearest 10, we need to decide if it goes up to 1,870 or down to 1,860. But if we want to round it to the nearest 100, we need to decide if it goes up to 1,900 or down to 1,800. And if we want to round it to the nearest 1,000, we need to decide if it goes up to 2,000 or down to 1,000. And in each case, the decision was based on which round number was closer to the original exact number. But you might be wondering, why would we ever want to make a number less precise in the first place? What is rounding good for? Well, rounding numbers can often make them a lot easier to do calculations with. Like, it would be a lot easier to quickly add 300 and 500 than it would be to add 312 and 498. Or sometimes you just don't need very much precision. Like, you might not need to know that your dog weighs 55.83297 kilograms. 55.8 kilograms might be precise enough. And some numbers, like repeating decimals or irrational numbers, have to be rounded off, because we can't just keep writing decimal digits forever. Okay, now that you know what rounding is and why we do it, for the rest...
Turn and tell your neighbor one reason why do we round numbers? Why would we want to round numbers in the real world?
We round numbers
and
is
talk
so
with Diana. And Rui, you can either scoot over or talk with Anna Van. Or talk with me, Rui. Why would we round numbers? Make it easier to calculate. Easier calculations. Awesome. Great, let's keep going. This is where it's going to get really juicy into those whole numbers and decimals. Watch the difference, what happens with zeros.
The rest of this video, we're going to focus on learning the procedure we follow to round off a number. You remember how our number system is based on digits and number places? Each digit of a number occupies a particular number place, and each number place is named according to the amount it represents, or counts. And it's important to know those names whenever you're rounding a number, because you'll usually be asked to round to a specific number place. For example, you may be asked to round a number to the nearest 10, or the nearest 100. Or you might be asked to round a number off to the nearest 10th, or 100th. You may even be asked to round to the nearest whole number, which is another way of asking you to round to the ones place. Okay, so when you're asked to round a number, the first step is to pay very close attention to which number place you need to round to. That number place is important because it represents the smallest unit of counting that you're going to keep in your rounded version of the number. In fact, that number place and the digit inside it is so important that I'm going to give it a special name just for this video. Let's call it the target. As I mentioned, rounding a number means making a new, less precise version of it. In that new number, any digits that are in number places smaller than the target will automatically get replaced with zeros. And in most cases, any digits that are in number places larger than the target will automatically be kept the same in the new rounded version. There are some exceptions, as we'll see later in this video. So that seems pretty simple. All the bigger digits you keep, and all the smaller digits you zero. But what about that target digit itself? What do we do with that? Well, we're going to do one of two things. We're either going to keep that digit the same, or we're going to increase it by 1. If we keep that target digit the same, that's called rounding down, which might seem strange at first. I mean, how can leaving the digit the same be rounding down? But remember, we're going to automatically replace all of the smaller places with 0. And doing that makes a rounded number smaller, even if the target digit stays the same. On the other hand, increasing the target digit by 1 is called rounding up, since the new rounded number will be larger than the original number. Alright, but how do we decide which to do? How do we know if we keep the target digit the same or increase it by 1? The key is to look at the digit in the next smaller number place, the digit that's just to the right of the target digit. If that digit is less than 5, in other words, if it's a 0, 1, 2, 3, or 4, then we'll leave the target digit the same in the rounded version. But if the digit is a 5 or greater, 5, 6, 7, 8, or 9, then we'll increase the target digit by 1. Okay, so now that you know the basic procedure for rounding numbers, let's try a few specific examples. Here's the first one. Round 24,623 to the nearest hundred. Since we need to round to the nearest hundred, we first need to identify the digit in the hundreds place. That digit is a 6, so that's our target. And we know that any digits to the right of the target will be replaced with zeros in our rounded version.
These are whole
Next, let's
numbers.
decide what to do with the target digit. We either keep it the same, or we increase it by 1. To decide, we look at the value of the next digit to the right. Since that digit is only a 2, which is less than 5, we round down, which means that we'll keep the target digit the same in the rounded number. Last, we just keep all the digits in bigger number places the same in the rounded version. There, we've rounded the original number to the nearest hundred, and the answer is 24,600. Let's try another problem. This one has some decimal digits, 32.725, and we're asked to round it to the nearest whole number. That means our target digit is in the ones place. We need to round it to the nearest 1. So any digits to the right of the ones place will just be replaced with zeros in the rounded version. Now, to decide what to do with the target digit, we look at the next digit to the right. Since that digit is a 7, we'll round up this time. That means we'll increase our target digit by 1. And finally, we keep any digits to the left of the target digit the same. In this case, that's just the 3.
Watch what
So we've
happens.
rounded this number off to 33.000, or just 33, since we don't really need those extra zeros after the decimal. Ready for one more? Let's round 65.7991 to the nearest hundredth. The first step is to identify the hundredths place as our target. That place contains the digit 9. All the digits in smaller number places will just be replaced with 0 in the rounded version. Next, we need to decide if we leave the target digit the same or increase it by 1.
Watch
So we
carefully.
look at the digit to the right of the target. It's a 9 also, so we'll definitely be rounding up. But since the target digit is already a 9, raising it by 1 is a little more complicated. When you add 1 to a digit that's already 9, we need to change it to 0 and increase the digit in the next bigger number place by 1. So that means that our target digit will become 0, and we need to increase the digit in the next bigger number place. That digit is a 7, so we'll increase it to an 8. The rest of the digits in the original number will be kept the same in the rounded version. So our rounded version will be 65.80.
Whoa. Oh, I went too slow. It's okay. I can fix it.
Will be 65.
What's happening to these zeros? They're going away. Bye-bye. Did I get to take these zeros away in a whole number? No. But in the decimal, the parts and pieces, these zeros that come after, to the right of the target digit, can go bye-bye after I round it. That's target information to remember. Let's finish the video.
5.80. As you can see, in some cases, rounding can actually change the digits to the left of the target digit also. It's sort of a domino effect that can happen when rounding numbers.
Don't do this at the store, you guys. What?
If you have a lot of 9s, rounding can bump them all up like a chain reaction. Like,
Check
what
this
if you
out.
need to round
Cool.
1,999,999 to the nearest 10? The 9 in the ones place tells us that we need to round our target digit up by 1, but it's already a 9. so we need to zero it and increase the next number place. But that's already a 9. So we need to zero it and increase the next number place. But that's already a 9. And so the pattern continues until we end up with 2 million as our final rounded number. So sometimes rounding a number is pretty simple, and other times it's a little more involved. The key is to remember the rule that if the digit to the right of the target is less than 5, we leave the target digit the same. But if it's 5 or more, we increase the target digit by 1, even if that causes a chain reaction with the bigger number places. All right, so now you know a lot about rounding numbers. You know why we round numbers, and you've seen the basic procedure in action. But just watching a video about rounding isn't enough to get really good at it. The only way to do that is to practice. So be sure to try rounding some numbers on your own. In fact, rounding is such an important math skill that you should probably practice it a lot until you've really got it mastered. As always, thanks for watching Math Antics, and I'll see you next time. Look.
All right, thanks, Math Antics. I'm actually going to turn this off since the iPad's not set up. I'm going to use the whiteboard, and I'll turn it back on when we need it. Yes, Autumn.
That sound effect hurt my head again.
Yeah, I need to figure out how to get this onto my computer so that way the sound is better. If you need to get a drink of water, you can go and do that. Okay, or let me know if your headache gets worse. I'm sorry that happened. All right, so rounding numbers. I'm going to keep going, David. Is this something urgent?
It's about the feature. I think you connect it by holding down the button as kind of, and then you got a Bluetooth transmitter.
Can you show me that not during class time? Thanks, David. Awesome. So, rounding numbers, I want to make sure we know the rules. If I have one of these numbers, 1, 2, 3, or 4, is to the right of my target digit, what am I going to do? How am I going to round? Jackie! What was that? I couldn't hear you. It's going to round, that target digit's going to stay the same, and we call that rounding down. So these are the numbers we're going to round down, and I'll put same in parentheses. Now, what if I had these digits? 5, 6, 7, 8, or 9. Riley, we're going to round up. Awesome. That part's kind of a review, right, from previous years of rounding? All right. Now let's look at these rules. If I am rounding whole numbers versus rounding decimals, and decimals are what again? What are decimals?
Pieces.
Parts and pieces, parts and pieces. So if I'm rounding whole numbers versus rounding decimals, what's that one rule that's different? Who can explain it? David, speak up real loud so we can hear you.
Alright, decimals don't become more parts, they become more pieces.
They don't become more parts and more pieces?
Never mind.
Okay, that's okay. It is a little bit confusing, no problem. What's the rule? What's the rule with zeros? What's going to happen with those zeros to the right of the target number when I'm rounding a whole number? Roman.
They're gonna see.
Yeah, I'm going to keep those zeros. I'm going to keep my zeros to the right of my target number. But in parts and pieces and decimals, what am I going to do? Maybe I should put an example on the board, and this will be a little more clear. So, whole number, if I am rounding 5,362 to the nearest, this is where the iPad's cool, so you don't have to keep switching markers. To the nearest hundredth place, what's going to happen? What's going to happen to my target digit? Mason.
The 6 is gonna become a 0 and the 3 is gonna be 4.
Okay. What about this too?
It stays the same.
Oh, This bumped up because it's a 6, and the 5 stays the same. So I'm going to keep those zeros. That's what I mean. Does that make sense so far?
Yes.
Awesome. New example. Decimals. What if I have and this time I'm rounding to the nearest tenth with a TH at the end. Tenth. I'm going to walk us through this. To the first digit to the right of the target is 3. So I'm going to round down, which means the target number stays the same. For now, I'm going to make these digits zeros. The digits to the left of my target number stay the same. Don't forget to put your decimal. What can I do with these zeros since it's in the decimals? Riley. I can take those zeros away. Bam. Bye-bye. So, the rule with decimals is I'm going to say, let's say swipe away zeros. It's like, swipe those tiny parts and pieces away because I'm only rounding to the 10th. Now, if I had a whole number and I used this rule, if I used the decimal rounding rule, if I applied this rule to whole numbers and I went like this, did I change the value of that number?
Yes.
Totally, by a lot, right? 54 is not the same as 5,400. That is why I have to keep those zeros. Did I change the value when I swiped those zeros away? I did not change the value. That's why I can swipe them away. Bye-bye. You ready to practice? Are you ready to practice?
Yeah.
All right, good. I'm going to keep this on the board. This is when we're going to go into the Pear Deck lesson. So let me get my projector back on. Oh, that means I can't keep this up.
That's fine.
No, I don't need the projector because I don't have the iPad. Talking myself through this. I'm going to be able to see. Oh. Yep, I'm going to be able to see what you do on the. So let me I'll write the Pear Deck code on the board for you. How's that? Well, actually, I'll leave this on and we'll see the code through the writing. Let me get it. Can you guys see that code? I'll write it over here for those who can't. I can hardly see it. RIKYBN. Wow, 9, 10 students already connected into my Pear Deck. Awesome. Whoa. 17 students. Awesome. You guys are getting really quick with logging into Pear Deck. If your neighbor needs help your neighbor. Yes, Andrea, go for it. 20 students connected. I'm going to open up my teacher dashboard. While you guys, oh no! You know what, you guys? This is a really great example of a growth mindset. I don't have the premium version of Pear Deck. Remember when Mrs. Scriven was asking that woman to buy Pear Deck? Please buy Pear Deck. So I have the free version, and it's just a version of Pear Deck where you can't use all the same cool little tools they have. So the tool that I'm missing right now is to be able to see all of your responses, which is the reason why we use Pear Deck. Is so that you guys can answer the responses. I can look and see the whole classes responses, help students as need, change instruction as needed. I can't do that without the free version. So this is when we keep the growth mindset and keep going. So this means we have to go back to old school ways. And we have to just close you can close your Pear Deck, we're not going to use this. And instead, get out a blank whiteboard. So you're going to have your place value whiteboard along with the blank whiteboard. So you're going to have two whiteboards on your desk. And I really appreciate your flexibility with all the tech issues. We will continue to learn no matter what. I'm still going to keep the rules up. Okay, let's keep the rules up. Okay. So this is how it's going to work. Instead of using Pear Deck, I'm just going to write the number up here on the board. I'm going to indicate the target place value that we're rounding to. You're going to round it on your
Whiteboard.
whiteboard, or if using this helps you, you can round it on, you can use this. If you show me your answer on here or your blank whiteboard, either way works. Use the tool that helps you. Am I making sense? Awesome. Let's give a whole number to try. Let's start with a whole number. Round to the nearest tens place. Round to the nearest tens place. You can use any of the tools on the board to help you. Once you have it, hold it on up. Round to the nearest tens place. Awesome. Yes. Yes, Emily. Yes. Maggie. Okay, now I want you. Oh, what's your digit on the ones place, Mason?
0.
Awesome. I agree.
I'm not good already.
Yes, Riley. Yes, Miriam. Yes, Maggie. Annie. Sorry for the name switch. Yes. Yes, yes. Awesome. Okie dokie. Next one. I'm going to do another whole number before I move decimals. This time I want you to round to the nearest. Well, first, who can tell me? What place value is this? Roman knows. Anyone else? It's okay. Look at your place value chart if you need to. That's a good tool. What place value did I underline on the board? A couple more people know. Rui. Hundredths place. Hundredths place is right here. That's the hundredths place. Maggie. 100,000s. What do you guys think?
Yeah.
Yeah, 100,000s. Does that make sense? Awesome. Round it to the nearest 100,000s place. Oh, I didn't realize I gave such a challenging one to start, but this is a good assessment. Yes, 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 yes. Ooh, I'm glad I gave a challenging one. If you are confused, ask your neighbor. He will be happy to help you. Yes, yes, yes. Oh, if you are confused, ask your neighbor. Ruby, let's see. Oh, I already gave you a thumbs up? So write that number on, you can write it on this side if you want, or on the plate. Yes, Natalie. Okay, I'm going to do this one on the board to help anyone who needs help. What happens? Attention up here. You're good, Roman. Thanks for helping. telling me 8 tells me to round up. Since 8 is 5 or greater, I can bump 9 up 1. And when I bump 9 up 1, it becomes 10. So I'm going to record the 0 here and move this plus 1 to the next place value when Emily gets back, Jessica. And this becomes 2 billion. Awesome. I thought I was going to stump you, and I didn't. Let's move straight into decimals. Mrs. Scriven is not back. She's really testing my teaching ability. Do you think I'm going to pass? Yes. Okay, let's try. Actually, I lied. I'm going to give you one more whole number, and then we're going to do parts and pieces. I didn't mean to lie. It wasn't my intention to lie. First, who can tell me which place value did I underline? Which place value is the target place value of Fina?
The thousands.
The thousands place. Go ahead and round to the thousands place. Thank you. Wow, look at you guys. Man, your previous teachers taught rounding well.
No.
Yes.
You were
yes.
my previous teacher.
Oh man. Yes, yes, yes. Let's see. Take a chance. Let's see. Just show me privately. Okay. But I'm going to show you, Anthony. Thank you, Diana, for helping. Okay. No worries if you are confused. Take a look up the board. All eyes on the board. What happens to all the digits? Jose, check this out. It's pretty cool. What happens to all the digits to the right of my target digit? What happens to those digits, Riley? They turn into zeros. Are you watching? Awesome. 0, 0, 0. What happens to my target digit? Ronan.
It's gonna round up 1 since the 6 is high as 5. But the problem is it'd be 10. So you're gonna add you're gonna add a plus 1 there, and add a 0, and then you're gonna move plus 1 to 5, and then that 6.
And what do I do with this 3, Roman?
It's gonna be the same.
Awesome. 360,000. Are you ready for parts and pieces?
Yes.
Don't forget about the rule of swiping away zeros. Ta-da! Here we go. Keep using. I didn't want to use that number.
No, 0. It's hard.
This time, who can tell me which place value did I underline? Which place value is our target place value, Jackie? What was that? I couldn't hear you. The 10th place. Yes, the 10th place. Make sure that decimal is really dark so I can see it, because I have to look. I'm not using my cool Pear Deck tool, so I have to look and see all those whiteboards. Yes, I'm seeing a lot of zeros swiped away. That's a decimal, not a comma. Do you see that this here is a decimal? Did you guys see this over here? Yeah.
Yes.
Okay.
I'm just
Yes,
wrong.
yes, yes. Okay, look at that rule. What happens with these extra zeros? Swipe those extra zeros away. Yes. Yes, we just went for it.
Awesome.
Yeah.
And we're uninstalling everything. We've been crazy. I couldn't call you. Phone doesn't work.
Yeah,
You're okay.
we're good.
Okay.
We did some extra math. We're just doing it. We tried Pear Deck and I realized I don't have premium, so I can't do the dashboard. So we're just doing old school.
I love it.
Yeah, instead
Take
of
your hat off,
wasting
please.
time.
Take your hat off. Awesome.
And we're learning how to swipe away those zeros.
Nice.
Okay, awesome. Let's try another
Right
one.
away, I love it.
Yeah. Okay, I didn't really fool anyone again. So you guys are on top of it. I'm gonna let you loose real soon here, and we're gonna work with flashcards. Let's see. That's totally okay if you don't get it right now. We're still learning. Okay, to start, who can tell me which place value is the target digit? Natalie, thanks for a quiet hand. Hundredths. That's correct. With a THS. Hundredths. Round to the nearest hundredths place. Round to the nearest hundredths place. Yes. Yes. Double check your hundredth digit, Marilyn. Yes. You rounded to the nearest tenth place. You want to round to the nearest hundredth place. Yes. This old school method is working pretty well. Javier, check out this rule. What do we get to do with those zeros? Swipe them away. Awesome. Thanks for helping, Roman. That's awesome. I'm giving more time. I see a few more people figuring this out. No problem. Yes, Jackie.
I see lots of smart faces right now.
Yeah. I think everyone in this room is smart. You all have different strengths and weaknesses.
Yeah, that was the long way of saying it. I see a light in your eyes that show understanding. That's what
All right, I'm going to do another decimal before I let you loose. Are you ready?
Yeah. I'm ready.
Awesome, Anthony.
Bring it on.
Okay, I will. Anthony. I'm going to bring it on good, okay?
No, Anthony, you just made it harder.
Anthony, why you exist?
You're welcome, everyone.
Thank you so much.
You don't need it harder.
Okay, Anthony asked me to bring it on, so I brought it on. Okay, who can tell me which place value is our target digit for rounding? Roman's on it. Who's another person who could tell me? Mason.
We are rounding to the thousand.
To the nearest thousand place with the THS at the end. It's also challenging for me. Oh. I don't agree, David. Look at it again. So I'm stumping more people now. Wait a second. I do agree, David, except you're missing a couple key things. I really brought it on heavy. I'm realizing how heavy I brought it on. I'm not giving thumbs up or thumbs down right now. I'm just giving a survey of what we're thinking out here. Because I'm seeing so many different responses. Anthony, you you made us rise to the challenge. Or you helped us rise to the challenge.
Thanks, Anthony.
Okay, so
Yeah, thank you so much.
I'm actually gonna write up a bunch of what I'm seeing. I have seen this. I have seen this. And I think these are the most common responses I have seen. So, okay, let me make a line here. Okay, to start, what's gonna happen to the digits to the right of my target digit? Javier.
We're gonna become zeros and we can take this away.
Right, they're initially gonna become zeros, and we know we're gonna be able to swipe them away. For now, let's just put those zeros up. But Javier's right, we're gonna be able to swipe those zeros target digit stays the same. Awesome. Now what happens to the digits to the right of the target? David.
It stays the same because it's not higher than the target. It's higher than the target.
Right, those are the place values greater than the target, so we leave them the same. Okay. What do I do with those zeros, Javier?
Swipe them away.
Swipe them away. So, awesome. You guys, I had to do that. I'm just going to be honest with you. I had to write these all on the board because I got confused while I saw all your responses of what was even going on. And I had to work through that myself to figure it out. So, awesome. We're learning all together. Okay, we have to do another one before I let you lose. One more.
Yay. Bring it on again.
No!
Yes. Yes.
Okay, let's see.
Bring it on harder. No. See, I love the class. I'm such a good person. Yeah, great.
Okay, which place value am I rounding to? Jackie. 10th place, yes. Go ahead and do it. I had to bring it down, Anthony. I didn't really bring it up. I brought it a little. Oh, check that 10th place value. Check the digit to the right of your target digit. Check out this digit. And which box does it belong in? And then make your correction. Yes. And what do I do with those zeros since it's parts and pieces? Swipe them away. Yes. Do you make your correction? Make your correction and then I'll move forward. Yes, Emily. Okay, Jose, what do I do with those zeros since it's decimals? What can I do with those extra zeros as
Swipe
units?
them away.
You got it, Jose. Let's see, Ruby. So since this digit is 5, what's going to happen to my target digit? It's going to move up, that's right. Alright, so the next part of this is you're going to get to practice in groups with these rounding flashcards. There's 2 sides to the flashcards. One side is whole numbers, one side is decimals. You're going to practice both sides with your partners. The same way I grouped you guys last time, I'm going to make you into groups of 4. Some people might be a group of 3. And you can break off into 2 pairs, split your deck in half, go through, quiz each other, and then swap decks. Does that with your little group of 4? Make sense?
If you want to challenge yourself, just look at the card because there's an easier one and a harder one on every card. Can I help you?
Sure. These are
Okay, sure.
All right, so Roman, Jose, Rui, and Anthony, you guys are going to be a group, and here's your cards to split up.
You can bring your whiteboard if you need it. Yes, of course.
I'll
Yeah,
go
bring
to
your
the
whiteboard. Of course, bring your whiteboard.
Okay, let's see. Anavea. Hold on, I'm gonna give you my number.
Oh, Diana, can you bring me number 3? And here's another box.
Opposite, come back here with Emily and Jessica. David, Javier, Anavea, and Autumn. You guys will be a four group. So do you two, can you guys move up here, please? Here you go, Anavea. You'll be with Autumn, David, and Javier. So you guys can move up here.
Do you need cards?
I got Anavea cards. Let's see who doesn't have cards. You guys, you four are good. I remember. So Anavea and David, you
You
guys
need
are
your
gonna pair, so then
whiteboards
you two are gonna
out.
pair.
So that you can write down your
So you
answers.
guys can face each other. Thanks.
Clark, I've got more cards. Do you want me to just randomly?
Yeah.
In a group of 4, just give a group of 4 more cards? Are you with them? Is that all the cards you have to keep here? What? Group? Yeah, for sure. Sure.
Yes. Thanks for sharing, Maggie.
Back and forth. Make sure that you're showing answers. That everybody has a chance to answer. Love it.
And then you just go Carmen, Jack. So I'm just
Write down the answer.
Okay, everyone has cards. Now Carmen goes with Jackie, and then Jackie goes with Mary, and Mary goes with Carmen, and it just keeps going in a circle like that. Does that make sense?
Yeah, like Carmen. Sit here, and then you girls turn your chairs.
Use your whiteboards. Use your place value charts as tools to help you. Are you guys both happy? Oh, cool. Let's see if you guys agree with your answers. I like that. Okay, so my target digit is in the thousands. What's happening to the digit to the right of the target? What box does it belong to? Round up or round down? Round up. So what I'm going to do here, can you hold it real good? Thanks. What's going to happen to this target? Okay, let's write it down. Yeah, write down your whole answer. That would help you. Way too large of a value to use in my head. So what happens to these numbers if they left as they target?
You don't have to act. You can put it between you and actually answer the. Both of you
What
can
did I
answer the
do?
same question. That's what you both are gonna do.
To the left, like my target What number did he say? 3,000. Did they stay the same? Did I change them? They stayed the same. So these digits to the left of your target stay the same. So these are all staying the same. You can just write them down. These aren't changing, right? There you go. Well, are these to the left of the target?
You do pen work?
Keep going. What's the next digit? Okay. And then what's happening to your target digit? Well, what's happening is since this is an 8, what's going to happen to your target digit? Look at these boxes. This is 8. You're going to round up. So what's going to happen to that target digit? Oh, you're here. Where are you using it? It's a 5 now. It's going to go up. To 6. So that's 6. And then what happens to that 8? Right. Wipe it away. You got it. So now that's done. So what number is this? 1,000. Good. Now, Anthony, you put in no. You guys go back and forth.
I see a lot of success happening. Lots of good math language and vocabulary.
I didn't remember to prompt them to write it down.
Some of them.
400 million. No, 58. Aren't you in Oh, I know. I'm just remembering that.
I love what you're doing. I love it. My heart is full. Keep it up. Keep it up. This is going to be on a quiz in a couple days, and I think you're going to ace it.
70 million.
Yeah, they said.
70 million in every
It gets you together.
You got it now? Awesome, Anthony. You're going to have about 1 more minute of rounding, and then you get a special treat. Yes, you do. I'm going to show you something.
So, what's this one? It was on purpose.
What is this?
Oh, it's on purpose. It was on purpose. I don't know why, but it was on purpose. No, you got it.
What's that?
Yeah, but this
Oh, damn it.
All right. We have people walking around collecting the flashcards. I have something fun to show you. But I'm going to wait till everybody is ready. All flashcards are collected.
Caps on your pens, whiteboards away, nothing to fiddle with. Boys, put your whiteboards away.
We can just bring those to the front and then we'll get them in boxes later. Thank you. Thank you. Thank you. Thank you. Thank you, David. So the projector's taking time to blink in, so I'm going to show you the cool video after recess. But before we go to recess, I want to remind you that if you did not finish your daily math quiz or writing check-in for homework, you will be working on it during recess. So if you are one of those people, please get that out and ready to work on. When we get back from recess, we'll view this cool video to end. It's like the wrap up of our rounding lesson. Sorry it didn't work before recess. You feel good? How do you feel about rounding whole numbers? How do you feel about rounding decimals?
Good.
What happens with the zeros when we round decimals?
Slide them away,
And what happens with the whole numbers?
You pick them.
Excellent. Excellent.
If
If you are doing the, who needs to be doing their math check-in from yesterday? Some people said they left their work at home. You need to take your whiteboard outside with you or a pencil and a paper. You need to have somewhere to do the math so that you can put an accurate score in. When I get my computer back, I can see. Anybody still need to do the writing check-in? Okay, then you'll be working on that. If you needed help, then just let us know, okay, Riley? If you need time, then this is your time. Needing help and needing time are different